Hello everyone and welcome back to calculus videos. You'll look at the screen right now and it's asking you to find the derivative of each of these functions. I don't actually want you to do that. I'm trying to make a point with something about what we're doing. So if you look at this first column here, you should know that you can easily take the derivative of each of these functions. You may have to rewrite this first one as x to the 1/2. But very easily, using the power rule, you could take the derivative of it. You could also take the derivative of x to the 5th. And now you can take the derivative of the sine x. If you look at what's different about the right column, is we no longer have just an x in here. We have another function, 5x, in there, which makes it a little more difficult to take the derivative of. If you look in here, it's not just an x, it's a 2x plus 6, which is in there. And again, we need to apply another rule. And sine x is no longer sine, it's a sine of 4x squared. Each of these functions is a composition of two functions. This one is the square root and 5x. This one is x to the 5th and 2x plus 6. And this one is sine x and 4x squared. What we're going to be doing is we're going to be learning how to use the chain rule in order to find the derivatives of those composite functions. But first, you need to know what a composition of functions are. You probably learned this in Algebra 2, maybe in pre-calculus, college algebra, but it's when g of x, or the inside, becomes the input of the function f of x. So normally we have a value here, or just an x. Well, now a function is being the input of the function f, and that's what makes it a composition of functions. You can rewind it back to the first slide that you saw, where you had the difference, a regular function and then a composition of two functions. So if you look right here, we have two functions, f of x and g of x. And what we're going to do is we're going to compose them. We're going to put g of x as the input of f of x. So if you look, as my magic appears here, there you go. And if you look, this is my inside function, this is my outside function. And that's important to note from when we use the chain rule to find the derivative of this function. Next one, we have sine x and 6x, and we're going to compose these two functions, and we're going to identify what the inside and outside function. So if you look, we have 6x, which is going to be our inside function, because we are going to put this in place of x right there. And using my magic, you will see that there is the composition of those two functions. Sometimes you will see the 6x in parentheses as well. So this is my inside function, sine is my outside function. Again, it's important to note the inside and outside functions when we use the chain rule. So take a moment and see, if I were going to put 3x plus 2, my inside function, into x to the 5th, what would it look like? So think about it for a moment. Hopefully you're thinking in your head what it would look like. And there it is. 3x plus 2, again, being the inside function, and x to the 5th, or that exponent there, being the outside function. So we're putting this inside where we see x to compose the two functions. Our last one here, x plus tangent x. And we are going to put this inside that. So everywhere we see an x, we are going to replace it with our inside function, x squared. And this is the result. We put x squared in for x to make it right here. And we put x squared in for x here. Again, you may see parentheses around this sometimes to group it as the angle tangent of x squared. Here's the chain rule. This is how I expect you to be articulating this in class. The derivative of the outside evaluated at the inside times the derivative of the inside. And we're talking functions when I say outside function, inside function. Let's look at some examples. Let's look at that first one. We're just going to pretend that we see this as our function. Here's our function. And we're going to apply the chain rule. We're going to find the derivative. Before we can find the derivative, we need to rewrite this. We know we can't take the derivative of a radical like the way it's written. So we are going to write it to the 1/2 power. So watch this. The derivative of the outside, that means we treat this just like we would if it was just x to the 1/2. So we multiply the exponent by the coefficient, subtract 1 from the exponent. Okay, so that's the derivative of the outside. Now, normally we have an x here, but the chain rule, if you go back, says the derivative of the outside evaluated at the inside. So now that means we have to evaluate it. Instead of putting x here, we're going to put the inside function right in there. X squared plus 1 times, if you recall again, times the derivative of the inside function. So the inside function right here, so what's the derivative of x squared plus 1? 2x. So now we're going to simplify. So f prime of x equals 2x on top on the numerator. Down here 2, and then the negative exponent. We're going to get rid of that, rewrite it, I should say. Our 2's are cancel out or divide out to give me 1, and I'm left with this for the chain rule. That is the derivative of this function using the chain rule. Let's try another. Let's look at that. F of x equals sine of 6x. So again, repeating the chain rule, the derivative of the outside. Well, what's the derivative of sine? Correct, cosine. So the derivative of the outside evaluated at the inside. So we're going to put our inside function back in there, and we're going to multiply it by the derivative of this inside. So what's the derivative of 6x? 6. And we're going to be left with that as our derivative. It's f prime, using the chain rule. The great thing about this video is you can stop it, you can replay it, you can go back to the beginning and say, what was that inside and outside? And just be prepared to come into class and have good questions, because you'll see some problems like this in class tomorrow. The next one, we had that 3x plus 2 raised to the 5th. So we've already identified what the inside and outside functions are. So what your job is take the derivative. So try it. Pause the video, see if you can't write that down. The derivative of the outside evaluated at the inside times the derivative of the inside. I'm going to continue on with that. So there it is. There's my derivative of the outside, just like the power rule, evaluated at the inside times the derivative of this inside. Okay, so taking a look at that, we're going to simplify this now. We cannot distribute that 5. We cannot distribute that 3 because of this exponent, but we can do 5 times 3. It gives 15. 3x plus 2 raised to the 4th power. And that's our derivative. We do not need to expand this, multiply it 3x plus 2 times 3x plus 2 times 3x plus 2 times 3x plus 2. We can leave the derivative just like that. Okay? I believe we have one more to look at, and that is that last one in there, that x squared plus tangent of x squared. So we're taking the derivative of this. Now, we're only taking it, even though it's a composition of two functions, x squared and that function x plus tangent x, if we look at this, we treat this just as we normally would. There's nothing special about this. This is just x squared, so we take the derivative, which is 2x. There's no inside, outside, because remember, the derivative of each, we can take the derivative of each individual component of this function. Plus, now here's where we have to use a chain rule because we have this inside function. So the derivative of the outside, just secant squared, evaluated at the inside, times the derivative of this inside, which is 2x. Alright? So again, derivative of the outside, the derivative of that tangent function, which is secant squared, evaluate at the inside, which is x squared, but then we have to take the derivative of that inside function, which is 2x. Alright? So let's simplify this, rewrite it. And if you watch it, 2x, 1 plus secant squared x squared. Right there, just back it up at 2x. And there's the derivative. Okay? So again, look at this video, watch it, identify those inside, outside. I'll even give you a couple practice ones to look at, so you can just identify, and even if you want to take the derivative, you may. So let's look at this. So look at these functions and say, what is the inside function? What is the outside function? And then maybe try to take the derivative of them. So as you're watching, taking a look and see, can you figure that out? So hopefully you're looking at them and trying to identify, oh, that's the inside function, that's the outside function. Try to do that, and then see if you can now take the derivative of them. And let's try one more. We did trig, we did some transcendental, we did an algebraic. Let's do this. There you go. All right, so be prepared to come into class and ask your good questions and practice the chain rule and do some problem solving with it. Okay? Hope you enjoyed this video on the chain rule. Have a good night. Johnstone out.